Welcome to this Docker tutorial. Today, we'll learn how to set up and use Docker to create a consistent, isolated development environment for web applications. To demonstrate Docker in action, we'll use Django, a popular web framework, as our example project. We'll be pairing it with PostgreSQL as the database, so you'll see exactly how to configure and connect these two in a containerized setup. To begin, we'll introduce the concept of Docker and why it's beneficial for developers. At the core of Docker is the concept of containers. Containers are lightweight, portable environments that allow applications to run consistently across different systems. They work by isolating a high-level copy of an operating system's user space, meaning that each container has its own file system, libraries, and dependencies, which creates a consistent environment for the application. Unlike virtual machines, containers don't need a full operating system. Rather, they share the host's operating system kernel. This makes containers much more efficient, using less memory and storage, while still providing the isolation needed to run applications independently from one another and from the host system. Docker is a platform that makes working with containers easy, allowing developers to create, deploy, and manage applications in isolated, consistent environments. By using containers, Docker ensures that applications run the same way, regardless of where they are deployed, whether on a developer's laptop, in testing, or in a production environment. In Docker, each application and its dependencies are bundled into an image, which is a snapshot that contains everything needed to run the application, like code, libraries, and configuration files. When a Docker container is started from an image, it creates an isolated environment that has all the dependencies and configurations defined in that image, sharing only the host's operating system kernel. This lightweight approach is much more efficient than virtual machines, which require their own OS. Docker containers can start up almost instantly, use far less memory, and can run multiple isolated applications on the same host. This isolation and consistency make Docker especially valuable for collaborative development, CI/CD pipelines, and cloud deployments. Developers can share their Docker images with other team members or deploy them in any environment where Docker is supported, knowing that the application will behave exactly the same. This makes Docker a powerful tool for modern application development and a crucial technology for microservices, DevOps workflows, and scalable cloud-native applications. In this introductory lesson, we're using Docker to set up a Django web application with a PostgreSQL database. By the end, you will understand how to containerize their Django project with PostgreSQL and be ready to deploy it seamlessly across different environments. Before you get started, if you haven't already, make sure you download Docker and create a Docker account. This will allow you to work seamlessly with Docker's tools and access additional resources for your development projects. To proceed with this Docker setup, we first need a Django application. This application can be either a new one we create from scratch or an existing project that you'd like to containerize. It's important to note that this setup will allow Django and PostgreSQL to run entirely within Docker containers, so they won't depend on any Python or PostgreSQL installations on your local machine. However, if you want to run the Django application outside of Docker, you will need to have Python and PostgreSQL installed on your computer. Let's walk through the steps to create a new Django application, which we'll later configure to run in Docker. I will assume that you already have Python installed on your computer. If not, please head over to the python.org website's downloads page, download and install the latest Python release for your specific operating system. With that aside, let's proceed with the steps to set up a Django application. Your Django project should be created separately, whether you're setting up the project locally or inside the Docker container. If you already have your Django project created locally, e.g. Yakuti, with apps like blog, templates, and static files, you will need to include those files inside the Docker container. If you're starting from scratch, you will need to create your project files using Django commands. Open a terminal window and navigate to the directory where you want to create your new Django project. To set up a new Django project, it's a good practice to use a virtual environment. Keep in mind that this step is just for creating the initial application. From there on, Docker will handle dependencies. Run the following command to initialize a virtual environment in the current project directory. Then activate the virtual environment by running source env bin activate, or on Windows env scripts activate. Use pip to install Django in the virtual environment. Now we'll create the new Django project by running the following command. To set up a Django project in Docker, you'll need a Dockerfile to define the image and a Docker Compose file to manage services. You will also need a requirements text file to define the dependencies that we will need to install for the application. You can generate this file by running the following command. In your project directory, create a file named Dockerfile to define your application image. Here's a basic Dockerfile for Django. Use an official Python runtime as a base image. Install dependencies required for building binaries, and remove cached package lists after installation to reduce the image size. Set the working directory. Copy the current directory contents to the container. Install Python dependencies. Expose the port Django will run on. The command to run the Django server. Now create a Docker Compose YML file with the following content. Define the services. Define the PostgreSQL database service. Use the official PostgreSQL 16 image from Docker Hub. Set the environment variables to configure the database name, user, and password. Define a named volume for persisting PostgreSQL data between container restarts. Define the Django Web Application Service. Specify the build context, the directory where the Django application is located, and the Dockerfile to use for building the image. Specify the command to run the Django development server on port 8000, binding it to all network interfaces. Mount the local directory to app in the container, allowing code changes on the host to reflect in the container. Map port 8000 of the container to port 8000 on the host, making the Django app accessible via localhost 8000. Set environment variables to configure the Django app to connect to the PostgreSQL database. Specify that the web service depends on the DB service, ensuring the database container starts before the Django app. Define the named volume, Postgres data, used for persisting PostgreSQL data. Now that we have our Docker environment set up for Django, the next step is to configure our database connection. We'll use environment variables in our settings.py file to make the configuration secure and flexible. We'll start by importing the OS module at the top of our settings file. This module will let us access the environment variables we've defined in our Docker Compose file. Next, let's modify the databases section in the settings file. Instead of hard-coding database details, we'll use os.getEnv to read values from environment variables, making the setup more secure and adaptable for different environments. In order to use PostgreSQL as our database, we need to add psychopg, which is the PostgreSQL adapter for Python, to the requirements.txt file. Now let's counter-check our files to make sure everything is okay. Next, start the containers by running the following command. At this point, the Django app should be accessible at localhost 8000, and we can verify everything is connected by accessing the app in the browser. Lastly, we cover some troubleshooting tips and testing. If issues arise, such as connectivity problems between Django and PostgreSQL, double-check the environment variables in Docker Compose YAML and confirm that the containers are up and running. Also, running basic Django commands like Python manage ploy shell within the container can help troubleshoot database connections or verify model configurations. Moving forward, here is one important thing to keep in mind. Since we mounted the local directory to the app path inside the container will directly reference the files in our local directory. This means any changes you make to code files, such as views, templates, or static files, will reflect immediately in the container without needing to rebuild. However, you'll still need to rebuild the container when you add new dependencies in requirements.txt file in order to install them, when you make any changes to the Dockerfile itself, like environment configurations or system libraries. Lastly, when you add a new Django app. In this case, a rebuild is often required to register the app correctly in Docker's environment, especially if your setup includes migrations or other database connections specific to the app. Again, with the local directory mount, code edits will auto-refresh in the container, streamlining development. For changes involving new dependencies, the Dockerfile, or additional apps, rebuilding ensures everything runs smoothly. The most important commands are docker compose build to build all your containers, docker compose up -- build to build and start containers, docker compose up -d to start containers in detached mode, docker compose up to start all your containers, docker compose down to shut down your containers, docker compose stop to stop running containers but keep their state, docker compose start to start containers that were previously created with the up command but are currently stopped, docker compose restart to restart all containers, which is useful for applying changes made to mounted files or configurations without rebuilding, docker compose logs to show logs from all containers, useful for troubleshooting and monitoring, docker compose exec to run a command in a running container, often used to access a shell or manage services inside a container. For example, to run migrations in your Django application, you'll need to enter the web containers shell, then run your migrations from there. To make this environment extensible, you can try adding more services, such as Redis for caching or Celery for task queues, or deploy your application to a cloud platform. I hope this video helped you get started with Django in Docker. Be sure to check out more resources, experiment with different configurations, and continue building out your Django apps in Docker for a more scalable development workflow. Thanks for watching, and don't forget to like, subscribe, and comment for more development tips and tutorials. See you in the next video.